Such ominous music. Sounds spooky. I don't know why I decided that this was the proper background for a build stream, but this is what I made. And I'm gonna roll with it for now, because I don't really see any reason not to. Everything sound okay out there? I think I'm a little hot on the mic. Alrighty. I think my mic's a little bit hot, but I'm really struggling to get the balance with it right for some reason today. Not sure why that is. It might just be my headphones, but it sounds like it's overdriving slightly, but we'll just have to kind of live with it, I think. Sounds okay now. How's everybody doing? I switched the setup a tiny bit, in that I kind of got rid of my monitors that had significant delay in them, but now I have a hot mic that I can't sort out. So, because it was really distorting earlier when I had to push it real hard to get anything out of it. So then I added a cloud lifter in. Maybe I should cut some of the low end. Maybe that'll help. That really might just be my headphones. I don't know. I am not sure. But anyway. Okay. Well, if you can let me know how that sounded, I'd appreciate it, because I can't tell if the issue is just local to me here or if it actually sounds that way on the stream. Anyhow, so, believe it or not, I actually tried to make this audio sound a little less ominous, but I apparently did not succeed. It really sounds like it's like a horror movie, and then it breaks to something more ethereal, but then it goes back to horror movie again. So we'll see if I can tolerate listening to that the whole time. We'll leave it be, but I might go in and make some adjustments if it gets to be too much. So we have we've got our enclosures built, power working. So I'm gonna move these, take these out of the way for the moment, because they will be important shortly when we start testing modules that we're building. But until then, we don't need them just yet. And so for the past 2 streams, we've been working through the Clacktronics Build Your Own Modular. For the record, I am very slow when it comes to DIY builds. Made evident by the fact that in the first stream I got the enclosures done. I mean, the first stream I only did like a 2-hour stream, but the second stream was a 4-hour stream, and it took me that long for the bus boards and the power supply, so go figure. I'm slow. But anyway, so we got the enclosures built, we got the power supply built, and sorry, I'm trying to see if I can set up a better view of the chat, but it looks like that's just what I'm going to have to deal with for now. Okay. So those parts are done, and just by way of background, I did say this on the other streams as well, so if you've been watching you'll know this, but for anyone who's new here, this project was released I think about 1.5 years ago, and I had pre-ordered it before it came out. One second, I'm just going to change the balance of the music real quick. It feels like it's, or the atmosphere. It's not quite music, I guess, but it feels like it's a little much. Okay, that might be a bit better. Let me know how that's sounding. So, yeah, anyway, back to the story. So, this project was announced, so I think it was maybe around like May or so of, I think, 2024. And as soon as I saw it, I was just like, this is a really cool idea, because it comes as a book where these sort of chapter markers are the PCBs. This one I already broke out a few from, so that's why you only have the one there. But if we go to the next section here, I guess we could work on the microcontroller today too, because that's part of this. What's that build look like? I was trying to get to something that just inherently on its own makes sound. I imagine the microcontroller you probably will have to load something too, which I'm not really equipped to do on stream necessarily. I could get that going, I guess. It does look pretty straightforward. But I think... yeah, that's a pretty simple build. I don't know. I guess this would be where I would take a vote on what to work on, but it's either going to be that or the VCOs, which they're two identical circuits. I have a feeling I'm going to go for that. But anyway. So I thought the project was really nicely done. It's a really beautiful project. All of these binder interiors, I don't know if this is still the case with new ones, but for the initial release anyway, these were all hand printed, so each one was unique. And then they have that same kind of splatter pattern that like laid out on the PCBs and stuff, which I think is really cool. And that extends to the enclosures and everything. So it's a really cool looking project. And then even better, in my opinion, is the fact that these chapters have fairly extensive descriptions of the circuits and sort of explain why they're designed the way they are, what the benefits and limitations are, and the various components and things used, all that sort of stuff. So this here is the build for the power supply. So we went through this on last week's stream after building the bus boards. The bus boards took a little while just because there's so many solder points, because there's 8 headers on each one, so it's, I think that's right, yeah, 8 headers on each one, so it ends up being like something like 128 solder points on each one, so it takes a little bit of time. And I'm just kind of slow and a little bit meticulous. You know what, let's go in order, because the microcontroller would be next, so that seems like the next step. I'm gonna shed my fleece here because I'm a little warming up. Hope everyone's doing well. Start of yet another week. These weeks go so fast lately. I mean, part of that might be just parenthood, but I think also I'm reading more and more people sort of expressing that same sentiment that the time is just whizzing by, and that's the exact same experience that I'm having. So I'll talk to you up here while I roll my sleeves up and things. Hello. But yeah, so it's been quite a couple months, but this past week I've been working more and more with Claude Code, and just the amount of output I can get done in a day now is crazy. I mean, in some instances I'm working with technologies that I'm not super familiar with, so I'm gonna have to get a little bit more proficient with, you know, best practices and syntax and things, and then go back and take a look at what Claude built, because, you know, I know enough to know when there's glaring problems, but which there haven't been many of, which is the impressive part, but maybe some of the more subtle things, I don't know if I'm necessarily at the point with modern Swift where I would recognize any pitfalls in that regard. Pardon me. Because it's all macOS and iOS apps that I'm building at the moment, so it's pretty cool though. You guys should let me know if you want me to do a coding stream, although I think I should stick to one project at a time, and we should finish this project first probably. But yeah. Okay, so let's get into it here. So last week I broke out this, which is the PCB for the microcontroller, and then there is a faceplate as well, which is here. So we should break this off as well. All right. Let's read through the material, see what the book has to say. Oh, so the other thing I guess I was going to say about this is I actually bought this when it was announced, and it came, I think it arrived in June, maybe late June of 2024, and it took me until now to build the thing. Part of that is because I have a gigantic, well, I have like multiple modular systems already, and one of them is just a massive studio rack. It's like a dual, like double 21U168 HP cabinet. So, you know, and I've probably built, I think last time I counted I had built like 65 or 70 modules, and that was a while ago, so I don't even know what the number is now. I'd have to recount. But so I've built a lot of modules, and I have kind of a full-fledged system. So this was just more, I wanted to support this project. I thought it was a really cool project. And so, you know, it was like kind of a shut up and take my money thing, but just from a support perspective. So it took me a long time to actually get around to building it. Yeah, really just because it's, you know, it's just extra. Now, one of the things I have been thinking of, because my daughter is only 6, but she has already demonstrated interest in synthesizers and things, although it's fleeting at times, so it's hard to tell if she's going to have any interest over time, and I'm certainly not going to force anything like that on her. But I did have the thought of, like, maybe this would be a fun system to give for her to play around with, but we shall see. Alright, so let's read through this, and then I'll pull all the parts, get everything staged. There is one thing that I might want to get from the other room, just because I am used to having, and I've mentioned this on the other streams, but this desk here is actually intended to be sort of more of a diagnostic workplace at this point, and I have a larger workbench in the other room where I have all my soldering and desoldering equipment and like my microscope and everything. So it just so happened that I already had the camera lines and everything run to this room, because this used to be my main workbench and then I expanded. So this isn't really set up the same way as it once was for building. It's more of a like kind of diagnostics thing. So I've got to make some sort of decision. I either have to keep the cameras here, use this desk for live streams, and this will just be my assembly workstation, and then like desoldering and disassembly will have to be one half of the desk in the other room, and then the other half would be diagnostics and like troubleshooting and stuff, and design. But I don't know. I can't decide how I want to work on that front. But I need to make more room because this is a cluttered mess for trying to like actually. I'm used to being able to spread out a little bit more when I'm building. Like usually have containers off to each side to hold things that are in, like one side is to hold things that are in process, the other side is to hold the parts and things that I have ready to go. And right now I'm just kind of winging it with I have to keep moving things around. There's just piles of stuff everywhere. So it's not ideal, but we'll get there. So for now, this is what I'm dealing with. So yeah, let's see what this microcontroller is all about. I did get permission from Ben at Clacktronics to kind of work through the material that's in the book on the streams, so that was very generous of him. That's cool, because I was just gonna kind of read through it ahead of time so that I knew all the steps and everything, and then just encourage people to buy the kit to get the information in here. But he said he's totally fine with me reading through it on the stream, so that's generous of him. So anyway, so the microcontroller, it says, of the 10 modules in Build Your Own Modular, this is the only one utilizing a manufacturer-specific component, a microcontroller development board. Microcontrollers are miniature computers designed for the electronic control of devices. They are ubiquitous in modern homes, found in appliances like washing machines, remote controls, and even within cars. Traditionally, they lack a user-programmable interface and just replace tasks previously handled by mechanical or basic logic circuits. In this modular project, we're intentionally incorporating a microcontroller for its flexibility and customization potential. I chose the Raspberry Pi Pico. Raspberry Pi is the company and Pico the product. Whilst microcontrollers exist in similar DIP packages as the TLO74 op-amp in the project, these are often older 8-bit models with limited capabilities and are usually aimed at the more professional market in terms of programming ease. The Pico, with its RP2040 chip, offers an easy user experience and is supported by a large online community. Loading a program can be as simple as plugging in the USB and dragging across a file. It can run MicroPython, an easy-to-use Python language interpreter for microcontrollers, but also run more sophisticated applications written in lower-level languages if desired. As it is modern, the surface mount QFN package of the RP2040 presents a soldering challenge. The Pico development board, on the other hand, provides a ready-to-use and affordable solution that can be placed in an easy-to-solder socket, so I felt this gave the best of both worlds. With this module, you have exciting options. Integrate it with your DAW, digital audio workstation, as a simple USB to MIDI to as a simple USB MIDI to CV controller or converter. It can act as a USB sound card or explore its full potential by creating your own unique experimental programs that run on the controller itself, such as sequencers, noise sources, or sample players. looks like it. Okay. Micro module. This module does not take power from the synthesizer, but from the USB connector. It has just about enough inputs and outputs to do something interesting. Most of the connections have a single microcontroller pin associated with them, so the GP general purpose pins found in the Raspberry Pi docks are labeled on the panel. That should make programming easier. Gate in, GP2, passes gate into the microcontroller. Gate out, GP5, outputs a gate from the microcontroller at 0 to 5 volt. CV in, GP26, reads 0 to 10 volt input and passes to the microcontroller's ADC, and that stands for analog to digital converter. We'll ignore negative voltages. CV out GP6 outputs approximately 0 to 5 volt CV. Knob 1, GP27, and knob 2, GP28. The microcontroller reads this through its ADC on GP27 and GP28 for adding controls to your code. LED 1, GP3, and LED 2, GP4, indicators that can be controlled by the microcontroller. Specifications. Power current is USB power consumption is 16 milliamps. Construction, build time, 1 hour. Difficulty, medium difficult. Microcontroller circuit description. So here we're going to get into, how this is designed and the idea behind it. So the circuit is fairly simple in design and primarily focuses on establishing a safe interface between the Eurorack's plus minus 10 volt signal range and the microcontroller's lower volt tolerances of 0 to 3.3 volt. The Pico will be damaged if its inputs or outputs are held outside these voltages for long periods, such as a negative voltage from CV. Interfacing a low voltage microcontroller involves protection measures to prevent damage to the microcontroller's pins and tricks to scale the voltages up and down. Digital input and output signals are managed through the use of single transistors. For analog input, the circuit incorporates a resistor voltage divider to bring Eurorack levels within the microcontroller's safe range, and then diodes to ensure voltages cannot go any higher or lower. On the output, a transistor and filtering is used to create a basic CV from a pulse width modulation output pin. So then there's the design for the gate in. When nothing is connected, the switch of the input jack holds the input to ground. When a jack plug is patched in, a voltage that exceeds the threshold voltage of 0.6 volts of Q4 will turn it on, pulling down GP2, which has an internal pull-up resistor. This means what the microcontroller sees is reversed. A positive 5 volt in will produce a 0 in code, and 0 volt will produce a 1 in code. D4 protects Q4 from, so that's a diode. Diode 4 protects Q4 from negative voltage inputs because NPN transistors can be damaged by reverse base emitter voltages. R13 limits the current, so there is a 100K input impedance, kilo ohm, yeah, whilst producing just enough current to allow Q4 to switch on. And then the gate out. The description is gate out is practically the same, except the micro drives the transistor instead and pulls the pull-up resistor, which is R17, between 5 volt and 0 volt. No need for the protection diode, as GPS only does, GP5 only does 0 to 3.3 volts. The base resistor is lower, so the transistor can turn on quicker. This is the full schematic here. I'm not going to go too in-depth with all of this. Again, I do recommend, if you find this interesting, that you should definitely purchase this kit and build the whole thing. It's very well put together. And then you can actually kind of take time and study the schematics and things, because they are very useful. CV in, when no jack is connected at the input is held at ground using the jack's internal switch. When a jack is patched in, resistor 14 forms a voltage divider with R15 and 16 to divide the voltage by a third. So 10 volt will become about 3.3 volt. Voltages at GP26 that are higher than 3.7 or lower than 0.4 volts will be shunted away by diode 5 and 6. This means GP26 will only see voltages on its ADC input when the CV input is between 0 to 10 volts. And then the CV out. This is somewhat of a cheap CV output because space is limited and we have no op amps. We have to use a bipolar transistor. There are a couple of ways to make a digital to analog converter without a specialized chip. One is to use a parallel output of pins and a resistor ladder, but we do not have enough space for that. Instead, I have opted for a PWM-based DAC, or digital to analog converter. PWM is typically used for LED brightness because the eye naturally filters out the flickering due to persistence of vision. In this circuit, we literally filter with resistors and capacitors. I opted to use a transistor as a switch to increase the gain of the PWM to 0 to 5 volt. Then I put the filter section afterwards. It was hard to get a linear response because when the transistor is on, it has a lower output impedance than when it is off. This is because the 5 volt comes through the 1K resistor, which is a higher impedance. This meant after filtering, as there was more impedance from the output of the transistor circuit when the PWM was near 100%, making the CV output a nonlinear curve. The solution to this is a bit of a hack. By increasing the base resistor to 100K, we bring the transistor's collector current way down, almost matching the impedance of the 1K resistor. That means the filter responds to the PWM in a much more balanced way, and duty cycle has a more linear relationship with voltage output, which now reaches all the way up to 5 volt. The downside is because the transistor base is now being driven very close to its cutoff, combined with a stray capacitance, the thinner duty cycles near 0% don't make it through, meaning we can't get to 0 volts. Also, the range depends on the exact value of the 100K resistor and the gain of the transistor, so it's not the best design, but the simplest and cheapest. And so here are the notes on construction. Use the bill of materials to place all the parts on the front side. Observe the silkscreen and images next to the bill of materials to make sure you don't solder the other components on the wrong side. Turn it over and install components like the potentiometer jacks and button on the other side, except for the LEDs, which are best installed after the panel is put on. Place the LEDs in their sockets, but don't solder, and put the panel over the pots and jacks. Use the nuts to secure the panel in place. Then push the LEDs through their respective holes and solder in place. Then install the special USB wire into the panel. It can be a bit tricky as the plastic tabs can get stuck. It is best to compress the tabs a little bit on a table edge before trying to fit it. Don't force it too much as the tabs tend to break. Once the USB is in, solder a small wire to the pad boot on the back labeled connect to TP6. Solder the other end to TP6 on the underside of the Raspberry Pi Pico as shown. Place the Pico in the socket with the USB socket facing downwards towards the USB wire. Put on the front panel feeding through the USB socket through the main board. Screw in the nuts on the jacks and pots to secure the front panel. The USB cable we just fed through the panel should plug into the Raspberry Pi Pico. Okay. Gotcha. Alright, so yeah, there's a small wire in the kit. Looks like that needs to be connected between the Pico and the PCB. Yeah, I see. There's a pad on the PCB labeled boot. Okay. And there's more information. This will be more relevant once it's built, but so programming, it says the Pico can be programmed a number of ways. My current favorite is using Thonny IDE and Adafruit's Circuit Python language, which is a fork of MicroPython, a stripped-down Python interpreter for microcontrollers. But you can also use it with Arduino IDE and straight-up C, C++ with the Raspberry Pi SDK if you wish. More details, links, and downloads on the Build Your Own Modular webpage. Above is an example of what the Thonny IDE looks like. There is a REPL for directly controlling it with commands at the bottom, and the code at the top can be executed and stopped real time at the top. Patching notes. CV ins and outs are general purpose, so it really depends on the program. If you plan to use audio out from the CV out port, you should pass it through the VCF or VCA to remove the DC element. Further hacking. The module actually has some expansion pins. On the back you will notice a footprint called Stemma QT. This allows you to connect a myriad of Spark, Fun, and Adafruit. I guess I'm always, I think both are technically correct, but I'm used to this allows you to connect myriad Spark, Fun, and Adafruit devices, but not a myriad of. But that's fine. Either way, I think both are correct. Anyway, this is just me being grammar police. This allows you to connect myriad Spark, Fun, and Adafruit devices to the microcontrollers such as screens, encoders, ADCs, DACs, or DACs, and sensors through I2C. All you need to do is solder on a JST to SH connector, which is a bit fiddly, so not included by default. There are also some breakout pins for I2S and USB host. More details are on the website. That sounds very interesting to extend it with. Okay, so we've got the PCB front, which is this. Is it this side? Let's see. Yeah, this is what he's calling the front, and then we have the back. Back is where jacks and pots go, and the button. Alright, this is quite a complicated build compared to the later modules. Take your time to make sure everything is right. The jack ground pins are shared. Fit both before soldering. You will also not really be able to test it apart from plugging in the USB and seeing it appear on your computer and flashing the LEDs. So you should come back to this after building the VCOs. Okay. Well, we might as well put it together anyway. So now to sort out all the parts, which I did not do in advance, obviously. So what I really should have done, if I had been smart, is I would have gone through and like basically made little kits for each of the modules and, you know, put their parts aside. I have 4 of these screws in the tray here, and I only need 2 of them, so I'm going to put those back. And then these can go back in the box. I was saying on the last stream, the PCBs for this thing are so pretty that even scraps, like this is technically a scrap, but it has that splatter pattern in the solder on there, or in the material on the PCB, so I end up like very tempted to keep all the scraps because they're so attractive. Like, I feel like I could do something with them. Well, maybe not all the scraps. I don't need these little slivers because I don't know what I would do with those, but it's all very tempting. Alright, let's see here. I'm gonna just clean up my trash from last time because I apparently left all this stuff in the tray and didn't clear it. Sounds like with this audio in the background. This, by the way, in case it's not obvious, this is actually guitar that we're hearing. It's just a loop that I made, and then it was a stereo loop that I split and reversed. So it's the 2 halves of the loop are cycling at different times, and they're reversed, and they're like pitched a bit, and then there's another instance of that kind of recorded over top with the RC600 with some additional guitar, and then that also is reversed and then playing back, and I think it is stretched a bit if I remember correctly, but so yeah, that's what we're listening to right now. So it's basically 2 loops on top of each other. I wish I could randomize the timing of them a bit more. Actually, I could but I'd have to set up a patch a little bit more than what I have now. Pardon me, just getting some water. And let me just, while I'm up, just verify everything's looking good on the stream. Cool, cool. Everybody doing good out there? Cool. Well, so... Alright, let's source all of the parts for this. But yeah, what I'm kind of wishing I would have done, and I think the other modules are more simplistic, so it maybe isn't as big a deal for those, but I do kind of wish I would have gone through the bill of materials for all of the modules and just made little kits so that I didn't have to sort out this part on stream every time. But, you know, it is what it is. We'll work with it. So, let's see. So, capacitors, there's just 2. It's a ceramic 100 nanofarad and another ceramic 10 nanofarad. Let's see, and there's cards in here that sort of identify what all the capacitors look like, which is nice because then I don't necessarily have to go searching their IDs for ones that I don't recognize. So we've got the 10 and 100 nanofarad. Where's the... okay. Alright, so there's 31, 100 nanofarad, 104s. Alright, so that's these. I just need one of these. That's the 100 nanofarad, and then for the 10, what are we looking at? There's only 2 of those on a card. I think that would be these because I don't think I've used any of them yet. Say no, that says K5K on it. That doesn't look like the right thing. Let me just identify what that would be. Oh, maybe it is. Oh, I see. The 103 is on the other side. Got it. Okay. 10 nanofarad. Yeah, this audio is funny. I don't remember if I even finished my thought earlier, but what I was saying was it sounds like I'm building some sort of a new technology that is going to save the world or like destroy it potentially, and we don't know which it is right now. Alright, so I think all the diodes in here are the same. Yeah. So how many do we need? 3. Need 3 diodes. think that's everything from the capacitor bag, right? We've got resistors. What else? Sockets. Oh wait, 2N3904. So no, there should be 292. Are those in here, or are those in a different? Oh no, those are in the IC bag. That's right. Alright. So, capacitors, diodes. These guys I might need my magnifying glass to identify. That's the other thing that I missed from... In the other room I have a... what am I trying to say? In the other room I have a microscope, and so while this little magnifying glass here is sometimes useful for identifying parts, sometimes because I don't have the actual like light on the underside plugged in right now, which I really should fix because it makes a big difference, but it's not super helpful all the time. So I need, which ones do I need? I need the 2N3904. Oh, that's what I was just holding. Okay. So we need 3 of those. So there's the transistors. Oh, I think the LEDs were in this bag too. Forgot. So we need 2 LEDs. I think they're just loose. Right? Yeah. Or drop things on the floor. There. Okay. LED. LED. Reclaim the capacitor that I dropped. This guy in here is the Pico. And then what else do we need? We're gonna need that socket. I believe is in here. Is it? Or is it not? Let's see. Okay, yeah, those are just the pin arrays that we're using, I guess, for that. These guys. I don't know why I called it a pin array, but header strip. I don't know what to call these. And what else needs to... last time I was putting little dots in here, so let's do that. That way I keep track of the things that I actually sourced so far without filling them off. We got the capacitors. Alright, we need all our resistors. We need our pots. 100K, two 100K pots. A tactile button. 4 Thonkakan jacks, USB cable, and I think that piece of wire is also on these packages in here. Alright, so this guy is the USB connector. I don't know why I call parts guys. Oh, is that what was in the other bag? Was it not enough diodes? There was, I forget. I think I have the note in here. Let's see what it say. Right. Yeah, and this is just sort of a testament to how awesome Thonk is. I got the kit originally. I didn't go through the bill of materials and stuff and like check all the parts and everything. And then I think it was maybe a week later, if that. Might not have even been that long. I got a package in the mail that had this slip in it and this pack of diodes. And it basically said, hey, we goofed. The kit requires more diodes, which is awesome. I mean, the fact that I've worked with different companies that produce kits and stuff, and a lot of times, if there's parts issues, they'll sometimes, I've had companies send me missing parts and stuff, but I've usually had to request it, and I've also had companies basically be like, oh yeah, sorry, and then I'm just on my own, and they'll like give, I end up asking for a part number or something, and they'll give me a part number so I can source the parts. But so the fact that Thonk just noticed the problem on their own and sent her, the extra parts at their expense. I mean, because I'm sure that postage wasn't free. I just was really impressed by that. I think it just is a testament to the quality of their work. All right, so we got 1, 2, 3, 4 jacks, and I'm gonna need 4 nuts for the jacks. Yeah, I said last week that I'm probably gonna end up either moving the cameras or just like kind of reconfiguring here, because this is so much messier than I'm used to having like a nice tray to lay all the parts out in and stuff, and everything here is multi-purpose and jammed, but it's okay. Alright, so all I have left is, I think, the resistors, right? So let me mark those jacks. I need the switch, the pots, and the resistors. Oh man, pen's running out of ink, I guess. Boo. Alright, we'll make it work. There we go. Kinda did it. Alright, we need 2 100K pots. Should be labeled on here. Yeah, B100K, that's 1. And B100K, so that's 2. I think also in here should be, I think the switch is in this bag. Maybe it's in a different bag. Nope, there it is. think that's the right part. It looks, I mean, it's the right form factor. It's just the depth of that switch is pretty long, but I'm sure that's just so that it reaches up through the panel. Okay, so we have our pots and our switch, and now we just need our resistors. But yeah, this kit is extremely well organized, and one of the things that I find, I mean, I'm not even a beginner, and for me this is really helpful just because I don't have to do all my, like, I basically have an app that will remind me, you know, what the different stripe patterns indicate on the resistors, because I don't have colorations memorized and stuff at this point. So I'll basically, usually what I'll have to do is, if I get a pack of resistors like this that aren't labeled, I'll have to go through and just kind of double check their markings to figure out what's what. But Ben at Clacktronics, the way he put this together is he included little sheets that explain which resistors are which makes it way faster, so I don't have to break out my app, so that's helpful. I guess what I probably should have done with the previous builds was, you know, mark the remaining quantities here, because that's the only thing, is I do sometimes go off of the number of resistors on the tape to identify which are which, but now some of them I've used, and so I've cut them down and there's fewer. So alright, so but what do we need? So we need 100R. So there's 6 of those. I don't think I've used any of those yet, so that'll be one of the smaller sheets. Okay, move some of these over here. Now what are we looking at? It's brown, black, 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 brown. I believe that's this. Let's check. Yep. And the other thing, what did I do? Oh, there it is. The other thing that I sometimes do if I have any doubt, and I don't have doubt here, but I'll just demonstrate. One thing that I would maybe do in some cases, if I wanted to verify that I've identified them correctly, is I'll just test. So as you can see, that's hovering right around, well, it's 99.6, 99.7, and there is a slight tolerance with these resistors. So that's 100 ohm resistance. So that's what we need. So then there's only one of those. Let me trim that off. Actually, so what I usually do, I kind of have a mess on my hands here, so I'm not set up the greatest to do this, but when it comes to resistors, what I'll generally do is I will place them all at the same time and then just solder them all together. So let me get set up to do that, because it's easier than having to keep track of which are which. Alright, so we've got all this stuff here. These are all the other parts. We've got our panel. Put the panel in there. We're going to need this PCB in a second. I do want to keep the bill of materials handy so I can mark things off as I go through. So now you get to witness the mess that is me trying to switch gears and get other things out in the foreground to work with. So it's a slow process. Like, okay, let's get these things out now so that I can do this task. Alright. So we can put that there. Get the book here so it's still accessible but out of the way. Push this back for now. This guy can sit over here. Alright. So what I'll usually do for a situation like this is I'm gonna look for, since I'm just doing the resistors right now, I'm gonna check for a spot in the board where I can kind of clamp it that, you know, won't interfere with the placement of the resistors. And for now, I'll just clamp it down with 2 clamps so that it's a little bit more stable. I mean, it's such a small board, it doesn't really matter. Alright, so R7 is going to be our 100 ohm. Oops. I'm going to set the other parts out of the way a little bit here. Oh, that's garbage from last time. I have to throw that out. Just set that there for the moment. I'll throw it out in just a second. Okay, that's just Apogee, or UPS delivering things from Apogee. Alright, so let's get these in the front here. Right, and so these were the right ones. So this is going to be R7. And we'll just bend the legs down right away. I'm going to push this back just a little bit. Make sure it's fully on screen. And where's R7? There's R7. And I mentioned in the last stream, but in case you're coming in newly. Okay, whoops. The pitch on these is a little bit different than the other board that I was working with. So they're more like... I'm mucking them all up. They're all bent. Closer. Just work it in, and if I have to tweak it a little bit, I have to tweak it. Yeah, these don't really. There we go. We have to. So what happened there was I bent the legs out further than they actually fit in the PCB, so I'm having to account for that on the one side here. Pull it through so that it doesn't have like a hump. Alright, there we go. So let me... this time I am going to mark off sheet that there are 5 left of the 100R, or else maybe I'll just make a mark to show how many I used. And then the 1R, I also used one last time, I know that much. Okay, so next we need 1K. There's 29 of those, which I believe is going to be that out of there. I believe that's going to be this strip. I'm just going to, yeah, it looks right, but let me just measure one of these real quick just to verify. Hold on, what would these be then? Oh, these are 100K possibly. Let's see, are these 100K? Yeah, okay. Alright, so these are the 100K. Do I need 100K? I do. I need, how many? 1, 2, 3, 4, 5. Oh, it's numbers over there. So I need 5 of these, so I might as well, since I have them. As well. One, 2, 3, 4, 5. So these were the 100R. I'm gonna actually just, rather than counting on the sheets, I'm just gonna label the tape. I don't know why I didn't do that in the first place. So these are 100K. There. These, I believe, let's just double check. I think these are the 100R. Yep. Okay, so I'll label that. So let's place these guys, or gals. Just put the garbage here. So these are, this guy's placed, so I'll put a dot there. We've got R2, R9, R10, R11, and R12. R2, R9, R11. I forgot R10. Whoops. R10, which is right next next to it. Okay, R10. And R12, right? R12. Okay, so let me mark those. R2, R11, R12, R10, R9. Great. So now let's try to find the 1K. Put this, because I know that's the 1R. Okay, yeah, okay, this looks right. Let me just test it. Yep. A little bit of tolerance shift there, but so we need 1, 2, 3, 4, 5. Label this with 1K. Okay, 1K. Put those back. And the last thing is 10K, which how many? Well, actually, let me. Okay, then there's. Oh, I see. 100K is 46. Just mark that I used 5 of those. All right, so let's place these. So these are R1. That's R1 there. Whoops. Bendy, bendy. R1, R4, R4 is here. Just gonna press those down. There we go. Okay, R5. Okay, there's R5. R6. closer to the board, just a hair. There we go. I think that's good. And finally, R8. Still not sitting as close as I want. Second. Alright, I guess it's gonna have to be good enough for now. I mean, it looks alright. Just a little wonky. Okay. And that's those gals, guys. I guess it doesn't really feel right for... well, I don't know. Guys doesn't have to be a gendered term, I suppose. Alright, so 10K, R3. So there's 17 of the 10K, and it's going to be brown, black, black, red, brown, which I have a feeling is maybe these. Yeah, that looks right. Let me test them. Yep, that's 10K, all right. So we need one. And I will label these as 10K. Alrighty, so that one is R3. That's this here. Okay. So that's all the resistors. So let me untangle the leads on my multimeter here and turn it off. It's gonna need new batteries soon, I think. The display's fading a little. Alright, I'm gonna get a drink of water and just check the stream and make sure everything's good. And then we'll get started on soldering these, then we'll do the diodes, and we'll work our way through. Oh, and before I forget, let's put the rest of these resistors back. Don't want anything getting misplaced. So cards in. This is looking like it's real close to the edge of the view there, so I'll push that back so you can see a little better. Alright. These go in the box. Okay. Box goes on the table. Right. Solder's all the way over here, so let me get that more accessible. Don't need these screwdrivers right now, so we'll get them more out of the way back there. Righto. So this is probably, yeah, this needs to be cleaned up a little bit. Been sitting too long. Just burning away. Alright, that looks clean. So with, as I mentioned last time, and I will just mention every time for folks that are watching newly, with resistors I go top down, and then I clip the leads and I clean up on the underside of the panel. I mean the PCB. Like so oh, you know what? I forgot. Gotta get my fume extractor going. I don't want to be breathing this stuff. Try not to block the view with it though. Alright, cool. But yeah, so I solder on the top side just for components like resistors and diodes where the pads where the legs are, you know, running through the PCB are accessible. That way I don't have to mess with like bending legs out to hold things in place and stuff like that. I find it a little bit faster. The thing you have to watch when you do this is to make sure that you're actually flowing solder all the way through to the other side of the board. And one of the ways that I do that is I'll just do a cleanup around when I cut the leads afterwards. I'll just kind of reflow and maybe add a little dot of solder sometimes if it doesn't look like it really covered the pad on the far side. So, also mentioned last time, but I am using rosin core, flux core solder. It is leaded solder. I bought 2 big reels of this a long time ago before I was even really thinking too hard about unleaded solder and things like that. And I just have such a large supply. My choice has been to go through this supply before I move on to unleaded solder and such. The one thing I will say is if you use leaded solder, I would be very careful not to inhale the fumes, which is why I use a fume extractor, which is basically just a big fan with a filter in it and a sort of adjustable neck cone thing so you can point it at your work. There's much cheaper and more like DIY type versions of this kind of thing that you can get very easily or make your own. But yeah, so you don't have to go and spend, I don't know what it was, like 150 bucks or something on, you know, something this official with an enclosure and everything. There's much less expensive alternatives. I just like this because it's very directional and you can kind of point it right at the work. It is a bit loud, but it's worth it. I think my mic is directional enough that you shouldn't get too much of the noise on this stream, but I'm not sure. Almost done. Got 3 more pads to solder here for the resistors. We can go through and mark those all installed. Okay. Step 1, let's release the clamps here, clip the leads, do some cleanup on the far side. So I use these sort of flat shears so that I can get as close to the PCB as possible. I try not to scratch it when I do this because you can scratch it. But yeah, I just get in there. Clip those leads. Oops. Drop things. Yeah, it looks like a couple of these didn't fully flow to the pad on the underside, so I will clean those up. I actually clean all of them up. I'm just really, I don't know, very meticulous about this sort of thing because I figure, you know, it's not like I'm running a production line here. I don't have to be as fast as possible in order to make my time profitable. So for that reason, I take my time, and I'm very thorough because I find it improves my results. I very rarely have projects that don't work. It is extremely rare, and it's usually a very simple fix when it happens. I think I've had, well, one time, actually, most recently, the one thing that I did encounter that threw me for a loop was there, with the Making Sound Machines workshop system, when I was building that, which I didn't do on a stream, and I should have, there was a trace at the edge of the board that connects the built-in microphone. Well, built-in microphone, you have to solder it in. It's a contact mic that you kind of install. But there's a trace right at the edge of the board that is where the lead for that runs on the board, and somehow a clamp or something, I'm not really sure how it happened, it got scratched and the lead got broken. So I ended up finally figuring out that was the problem, because things weren't working as I expected. Like, I wasn't getting audio from the contact mic, and all the solder joints had continuity and everything, and I couldn't figure out what was going on. And finally I realized that there was a trace on the board. I think it must have been, like, I finally tested 2 points on the board for continuity that I hadn't tested previously, and it turned out that there was a continuity break, and so I ended up having to just take this tiny strand of copper wire and solder it across the points where the trace was broken, and that fixed it, and then it was fine. But it was a bit of a goose chase until I found that problem, because it wasn't obvious because it was so close to the edge, and it just looked like sometimes at the edge of a board, like, you know, if they were connected to another PCB in manufacturing and they've been cut off, sometimes they'll just have marks along the edge. And I guess the trace was so close to the edge that I just didn't even realize that anything would have been running along there. It just looked like a little scratch on the board. It didn't look like any big deal. And it was right at the edge, but it turned out it broke a trace. And I think it must have been one of my clamps or something. I don't know what could have done it, but I did look at, like, before and after pictures of the process, because I was taking pictures of the board as I went, and sure enough, like, one didn't have it and one did, so somehow I damaged it, but I don't really know what happened. But I fixed it, and so that was good. Okay, so resistors are good. That stuff's done. So now I'm gonna install the diodes, because those are the next closest thing. So what the sort of generally accepted order that you would normally do things is kind of, you know, surface into higher components, and going in that order, so that you don't have to work around larger components trying to fit the flatter things to the board and all that sort of stuff. So so that's where we'll go next. Sorry, I'm just throwing out those scraps of leads. I used to collect them thinking that I would do something with them. I have no idea what I thought I would do with them, but I don't like waste. I try not to make a lot of trash. I try to recycle things as much as I can, but out here, recycling's kind of hard. Where I live, there's just not collection for it or anything, so. Anyway, let's get those diodes in. Alright, so there's 3 diodes. And I'm not sure how well you can see this, but they're basically silk screened with a white bar on one side, and then if you look at the diodes, they have like a silver cap kind of on one end. Well, it's just actually a stripe. It doesn't go to the whole, across the whole end, but we've got a silver stripe that it indicates the polarity and which way voltage flows through it. And yeah. So I think, do I have, I thought I had, oh, there they are, they're way over there. Let me get my needle nose pliers, because these leads are a little thicker. I don't like, I feel like when I bend them by hand, they're not always the cleanest, so I'm gonna go ahead and bend them with my pliers. Actually, these look like they have a little bit of a wider footprint, so let me, perhaps I will use, let's just check here. Is that going to be good if I do it? Yeah, alright. We'll use this guy. Alright. Does that fit? Sure does. Cool. Alright, so install the diodes. And in case you're new to circuits and things, diodes basically, I feel like resistors are just in the name. You can kind of understand what they do. They insert resistance into the circuit so that you can drop voltages and things. With diodes, they just allow current to flow in one direction, and so they can be used to protect circuits from voltage flowing into components that it shouldn't, things like that. Or you can also use them to protect against overages, things like that. In case it's not obvious, because I move kind of slowly when I'm doing these builds, that's the reason for choosing somewhat meditative sounds for the background. Because I figure I want these streams to just be sort of relaxing for anyone who chooses to watch them. One of these days I'm just gonna patch up like a binaural beat on the modular and we can all meditate the whole time. Alright, see how those look on the other side. Okay. A little weak. I'm gonna have to reflow that, make sure it has a little solder on the underside of the board here. Okay, clipped all the leads. Now we'll just go in and clean those up real quick. Stick the corner in here, that should be enough. My solder. Good. That one's good. That one's good. Okay, these guys. Let's get this one done. Okay. Lovely. Alright. Looks good. So, what next? Let's mark off the diodes. Oops. So, pardon me. Q1, Q2, where's Q3? Oh, there's Q3. Okay. So we've got our transistors. Maybe those will go next. Maybe I'll do the capacitors first. Have to find them. Alright, C2, where's C1? Okay. Let's install the capacitors first. with ceramic capacitors like this, I also sometimes do, like I sometimes solder them from the top side. I do, just real briefly, have to remind myself which is which on these designations. I have a terrible memory for this sort of thing. I don't know why. So we've got 110. Right, so the 10 nanofarad is the 103, and then the 100 nanofarad is the 104. Cool. That's what I thought, but I couldn't remember. Righto. So 103 for C2. It's really taped on there. Sometimes these are easier to get off these strips than other times. This one's really stuck on. A lot of times you can just like wiggle them a bit and they pull out of the tape, but this one's really in there. Ouch. Okay, now that I mangled the leads a little bit, but it should be fine. There we go. Alright, we'll also put C1 in. Alright, now let's solder that in real quick. Clean the tip first. I'm reflowing that because, yeah, okay. It looked like slightly cold joint for some reason. Alright, now that should be good. Okay. Same deal. Clip these leads, clean them up. Let me just clean up those pads on the underside, make sure they've got enough solder. Okay, that's that. So we've got our capacitors. So I would say now let's install the transistors. Notice we're going taller and taller with our... Now the one thought I have is whether or not I want to install that wire before I install something here. So these, I don't think these need any alteration. I think they're just straight up, right? They just go in. Yeah. Okay, so we're going to be installing these headers here, and once that's done, then this pad in here is going to be a little less accessible. It's not bad. I'm just trying to decide if I want to install that before I install the... Yeah, why not? Let's just make it easier on ourselves. So we'll do the transistors after I do this little wire lead. So this, with stuff like this, is where like helping hand kind of things come in handy. So I'm just gonna set this up. Looks like I need to strip it. Let me get my strippers. So there's no like end exposed on this wire, so I'm gonna have to just strip the insulation off real quick and give myself something to work with. Okay. That end. And then we'll do the same on the other side. Cool. Doesn't need much, just needs to make contact. So, right, so then what I would do, I think in this case, is we'll just kind of align it with the pad and use one of these helping hands to just hold it in place, essentially, while I heat everything. Not the most precise way to do this, but as long as I can put a little pressure on it and the pad at the same time, it should be good. So we'll go in here. Let me swivel this a little. Just a little. There we go. That's a good alignment. Press that down. Just kind of hold it there, even though it's hot. Good, didn't burn it. Okay. Cool. So that is in place. Just double check before I move on to make sure that that matches. Yeah, pretty much. In the image in the book, it's bent up a little bit higher, but that's fine. That'll work. Okay, so then let's get our transistors. Remember, they're just loose in here, is that correct? Where are they? Where'd they go? Oh, they're there. They're not loose. They're on tape. Okay. So, with these, their orientation matters, so you want to always follow the silk screen on the board. Flat side goes to the flat side on the board. Simple as that. And again, what I tend to do with these is I will place them Now these I usually don't fully solder from the top side, because I usually can't access the middle lead too well. But I'll just make sure they're relatively straight, and I will tack in like one of the pads on the sides just to stabilize them and make sure they don't move around. And then I'll flip the PCB over and handle the other side. So I'll just go ahead, and space is getting a little tight here, but not too bad. You just want to make sure the iron doesn't come in contact with any components that it could damage. So that's nice and straight. And the way these are, like, I mean, even if that's not the best solder joint, it's really just to hold it in place. So as long as it's not a completely cold joint that's not even in contact with the pad, then it's doing its job. So, so then I'll flip the PCB over, and we'll do the actual soldering on the other side. But this way, they're all held in, they're secure. Thing to be aware of is to not start with the leg that is the one that's secured, because then the whole thing will just fall out usually. Okay, there's one. Two. Three. Looking good. It's leaning just a tiny bit, but so there you can see those are now solid. So we've got our transistors. I'm going to go ahead and clip the leads underneath. Clean these up. A lot of times I'll hold the PCB against my chest so that it doesn't go flying anywhere when because I'm holding it by the leads basically, so I don't want it to go anywhere once I've clipped them all. This lets me keep it stable. Alright, so those are cleaned up. In a case like this, they look good, they're solid. I'm not going to do anything more with them. I'm just looking closely to make sure nothing's bridged, but it looks good. Alright, so we can mark those off. Those are good. Alright, so now we'll do the socket, which is basically just two strips of female headers So I'm going to use my standard approach to this kind of thing. Just going to use a helping hand to hold some solder in place, and I'm going to tack in just a couple pins at the end to make sure the thing's secure. Get centered as well as I can in the holes before I do this, because that will affect how it sits. So I just heat the pad and then I kind of press the solder up in place, and I'll just do both ends of the header like this way. Once that pad's hot, it should just melt the solder right on there, which it's doing. So there we go. So that one's, the idea is to just secure it. So now we'll add the second header. And if you choose to take this approach the way I'm doing it, the one thing you want to be extra careful of is you want to make sure it's flush and like very solid against the board. And I'm just super kind of silly and OCD about alignment of parts and things, so I'm just making sure that they're actually centered in the holes, like the pins are centered in the holes on the PCB as well. You don't necessarily have to do that. The tolerance should make it such that as long as it's straight, you want to make sure it's straight, because otherwise you're putting unnecessary strain on the pins on the, in this case, the Raspberry Pi Pico. Alright, so those are locked in. So the next thing that I'm going to do then, I'm wondering if I'm going, because there are some solder points that I have to access between the two headers. I am wondering if I'm going to wish I had installed those first, but I don't think that's going to be the way of it anyway, because I need to place those, then place the faceplate, make sure everything's fits and is aligned, and then do it. So this should be okay. We'll go with this. I'm going to just kind of clamp on this far corner here to give it some stability. Can get rid of this guy that's holding the solder, and now I'll just go up from the bottom one pin at a time and get all these soldered in. One, two, three, four, five, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19 and 20 were already done, so that's good. Though I guess just to be extra safe, because of how I flowed the solder on those, I'm just going to reflow those last two real quick. Alright, now we're good. Okay. about. One more. And now let's just, to be safe, reflow those ends. And we're good. Okay, so now we have the headers. I'm gonna mark those. Oops. So now it's really just, we'll need to install the actual Raspberry Pi, but first I'm going to go ahead and install the hardware on this side and the LEDs. We won't solder the LEDs yet until we have the panel in place, and then we should be able to kind of put it all together. So we're almost done here. So first thing is the pots. Just kind of make sure everything fits in place. You might, when you're installing these, you might have to give them a little bit of a squeeze to get those side pins engaged. And if the leads are a little wonky, sometimes they get bent. You might just have to straighten those out, but these look good. So there's that, and there's our switch. That looks good. We'll drop the LEDs in. Long lead is positive. Oh man. I said on the last stream, like, I have almost this weird OCD thing where even though I know how the orientation should be, I always feel the need to check. Like, just verify. I don't know why I do it. I mean, I don't know how many years I've been building stuff now, and I still do this, and I don't know why. It's like OCD. I should just trust myself. Tools. Yeah, that's all right. Everything's correct. I don't know why I won't just trust myself with those things. I'm always correct with it. I'm always doing it the right way, and yet. Alright, so now for the jacks, these actually share a hole for the ground pin, so sometimes squeezing these in will take a little bit of doing. These don't seem to be too bad. Nah, those are fine. They just went right in. So the idea here, that pin's a little bent, so I'm gonna, okay, there we go. The idea here is to place all these, then place the panel, and just make sure that everything is aligning properly, and then you can tighten stuff down, and then you do your soldering once everything's tightened down and aligned and everything to the panel. Right. So that looks good. So one thing I did forget to pull out of the part bag is the washers and nuts for the pots. So I do have to grab those, because I'll want to tighten those down before we do the soldering for this here. And At this stage, I just hand tighten everything. I'll go through and properly tighten them later, once everything's secured. But yeah, for this, it's just hand tight. Okay. So we're almost there with these guys. So get that on. And okay, so those look good. Those are hand tight. I'm just going to stick this in here for now, the clamp to kind of hold everything in place, and then I'm going to get a set of washers and nuts for the pots. So I think those are actually in a separate bag, which is why I overlooked it. Yes, there they are, nuts and washers. So we'll need 2 of each. Oops. And I think these are all the same size, because I think all the pots are the same setup, basically. So we got that. Okay, there's that. I just realized that I think when I streamed last week, I don't think I added to the description the links for purchasing this kit and such, so I will be sure to do so. So once the stream is posted on YouTube, I haven't been archiving anything on Twitch. I just I stream, and if anyone picks it up, great. If not, great. But on YouTube, everything I stream gets saved. So because they're under, I think I forget the cutoff. It's like 12 hours or 11 hours or something. But since they're 4-hour streams, they get saved immediately on YouTube. And so I will go in and edit those descriptions to make sure that the links are there. But all you really need to do is just go and search for Clacktronics, build your own modular, and you will find everything you need. Or you can go to Thonk, because these kits are available on the Thonk website. Alright, give me 1 second. I need to get a piece of packing tape so that I can make these LEDs flush with the panel, and while I do that, I'm going to also throw out all this trash here. Okay, 1 second, I'll be right back. Alrighty. So what I do with LEDs like this that push through the panel, I'll take just a clear piece of packing tape like this. You could use any tape, as long as you can pull it back off easily. And I just squish them up, stick them to the tape, like so. And then that's how I'll solder everything. And then that way, they're nice and flush with the panel. They tend to look pretty good when they're done. I think Ben wrote in the book that he likes to poke them through the panel and have them protruding. I don't mind that look, but I like the panels to be, you know, clean and free of distractions if possible, so I tend to just poke them through like that. But anyway, alright, so it is some close quarters in here for soldering the button and the pots, so that'll probably take a little bit of extra care. So I'm going to start down here with the jacks and clean the tip of my iron again. Okay, see, that's nice and clean. Like the you know, the tip of the iron is heat damaged at this point, but the actual tip, if you see, is nice and tinned and clean. So that's what your tip, that's what your iron should look like. If it's pitted or wacky, that's usually an indication that you aren't cleaning it off often enough. You aren't keeping it clear of like you're either kind of burning it and not cleaning it enough or whatever. But as long as the iron's hot and it's well tinned, you shouldn't have any problems. Okay. I still keep I'm amused by the guitar loops that I made, because it really does, like the way the tonalities it moves through, it really kind of sounds like this is a really important project that the whole world is depending on, and I might fail and everyone might die. But also I might succeed and everyone might survive, but we don't know yet. Alrighty, so the jacks are good. Now let's go in and get these LEDs carefully. Again, it's pretty close quarters in here for this. I'm just carefully angling my iron into this spot here, making sure it gets heated well without touching any of the headers around it. Looks good. Let's get this one. Okay. Alright, so that's good. I think what I'm going to do for the remaining solder joints is just flip the thing around. Now we can get this wire out of the way here so it doesn't get scalded in the process. And I'm going to work my way up towards the top of the PCB, starting with the switch pins. So we'll just kind of carefully get in here. I'm not making a ton of contact with the pad, so I have to be a little patient to make sure it heats it up. There we go. Same with this one. There we go. That's two more to do. Looks good. Hopefully my head's not in the way here. Alright, so the switch looks good. A little heavy on the solder on the last one there, on the last pin, so I'm going to reflow that just a tiny bit. And maybe same with the one before it here. There we go. Okay. Alright, that looks good. So now we'll do the top pot. There's that. 1 pin, 2 pin, 3 pin. Not everyone solders these sort of connector pins that just kind of hold it into the board, but I do, because I find the knobs feel more secure that way. Shouldn't make a huge difference, but I like to solder them. Granted, if you have to you know, ever remove or replace the pot, then that's just more joints that you have to handle. But I think I also got into that habit because not every design uses nuts and washers to mount a pot to the board. So sometimes, I mean, to the panel. So sometimes some modules will be designed in such a way that they're just kind of free floating. And if you only solder the pins, and that, you know, you can potentially be putting a bit of stress on those pins, which I don't like to do. So but I know there are debates out there as to whether or not you should do what I'm doing right now, but I just do it. Plus I have a desoldering station, so if there's a problem, it's really not a big deal to remove those. Okay, so we're getting very close to being done here, so that is solid. Everything's looking good. I'm going to clip the leads for the LEDs to get them out of the way. So carefully, because it's tight quarters here. Get in there, and there's that. Okay. That looks good. So now I can take this tape off the front panel because the LEDs are soldered at this point. So let's do that. Get rid of that. Brr. Ah, I tore it. Bummer. Okay, there we go. So that's nice and clean. Those are nice and flush with the panel, if you can see. And these feel good. Everything feels solid there. Push button is good, just almost flush with the panel, just sticks up a little bit, just enough to activate it, which is great. Jacks are clean, everything's mounted well. So the next thing is to install the USB port in the front here. So this will come through, and then just carefully did indicate in the book that this can be a little precarious in terms of getting it to cooperate without breaking the pins on the side. So far so good, I guess. It's going in. Just want to be gentle enough with it. Okay. There we go. Perfect. Alright, so that does sit just slightly loose, like it kind of bumps around, so that's a little weird. Wonder if it's possible to just very carefully push those pins out just a tiny, or you know, whatever you want to call them, the plastic tabs on the sides. I'm going to see if I can just very carefully encourage those to stick out just a little bit more like they were before I inserted it, to see if I can get that to be just a little bit more secure in there. That's not going to do it that way, I don't think. Okay, so what I might do in a situation like this, because I don't like how much that wiggles, that's going to annoy me. I don't have my glue gun handy, but I have a hot glue gun, and what I'll probably end up doing is I'll probably just put a dab of hot glue on either side of the jack on the back of the PCB here, so that it can't wiggle around, it's like held down. But for now it's fine. Just kind of loose and weird. Alright, so let me just double check what the book has to say about that, because I do remember it talks about the installation there. Let's see. Put on the front panel, feeding through the USB socket through the main board. Screw in the nuts on the jacks and pots and secure the front panel. Alright. Well. Okay. So it should plug into the Raspberry Pico, but it doesn't say anything about fit. So I guess, given that it looks loose in the image there, I'm going to say that it probably is expected to be a little loose, and I can fix that. So I'll just deal with it that way. So now the only thing left to do is to unwrap the Pico. So we'll unwrap the Pico. And I'm going to have to solder the one wire in place. I have to double check which terminal or connection it goes to there. And then we should be able to proceed. So here's the Pico, looks good. And let me double check. So alright, so it needs to go to TP6 on the underside, which it's going to be a little hard for you to see, I would imagine, but it's the third pad on the underside of the Pico here. So I am going to just, I guess, kind of grip this here, place this next to it, and then might just use my hands. There's already solder on the pad. I have to see if it's enough for this to sit. If I heat it. Okay. No, we're gonna do this differently. So I'm gonna add a bit more solder. Okay, then we're gonna slip this in there. Oops. There, that should be good. Okay, and then we'll just double up a little bit more. Hold that in place. And just a tiny bit more solder. Alright, that seems secure. So then, does it show the final assembly? Which way? Okay, yeah. Looks like it. Yeah, so the debug socket points up. So then this just mates in like this. That looks good. And then this plugs in here. Got a bit of excess in the way of wire here, but that should be okay. Alright, so in theory, minus some hot glue to hold this in place, and obviously the knobs, we need to install the knobs, this should be done. We should be solid. So the thing to test would be to plug this into a computer and make sure that the, there we go, that wire that I installed was actually caught between the pin headers and the headers on the board there, but I fixed it. Alright, so we can turn the fume extractor off for now. Alright, let's get some knobs. Bag of knobs. Take 2 of them. Okay, let's install those. So we'll turn that all the way down. And then we'll just kind of, I'm going to assume that that's going to be a good position, but let's run it through the range and see. So we're there and there. That's alright, I guess. Points down a little bit further at max than it does at minimum, so I'm going to change that by 1 notch. There we go. Alright. So that looks good. That's the full range. And then we'll make sure that one's turned all the way down, and we'll just install it to match exactly. So install that there. And make sure that when they're both turned up, they're looking about. Yep. All right. So they match. And there we have it. So now, let's test it. I have confidence. I think it should work. Now this module does not take any power. So, I'm trying to think. Yeah, I guess I'll go into the other room. Let me just check something here. So, let me just switch here. Oh man, I hope that... Oh. Huh. Hold on a second. What's Well, darn it. I missed the chat. Sorry, Patricia. Oh, that was nice of her to stop in. I did not catch that, unfortunately. Alright, so when was that? That was not that long ago, actually. Hold on. It was like 15 minutes ago. Darn. Oh boy. Okay, well, I have to keep better eye on the chat, I guess. So, let's just real quick thinking through the logistics of this, because there's no open ports on my computer at the moment, but just real quick, hold on 1 second. One second. Okay. Doobie 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 doo. Alright, so let's see. I need a USB-C to USB-A cable, I guess, if I'm gonna not disconnect any cameras or anything while I'm running here. Or the monitor, for that matter. Gotta love the abundance of ports on Apple laptops. Always so helpful. Let's see. Do I even have a USB A to USB-C cable nearby? I do think these can work kind of in reverse, if I remember correctly, so maybe I can do it this way. Thinking. So, I think that will work, but I'm not 100% positive. This is like the eternal problem. It's always, in my studio anyway, I don't know if anyone else experiences this same thing, but I'm always just having to find cables that I have like hundreds of, if not more than hundreds of, and I'm just like always having to mess around trying to figure out like some way to adapt something, or it's like I have a cable like that, but I have no idea where it is at the moment because my cables are just not organized, and they should be, but they're not, and it's a bummer. And one of these days I'll take the time to do it, but alright, so instead of this nonsense, because I don't know that this is going to work if I do it like that, let's go ahead. USB-C cable. I'm trying to think what the best approach would be here. Oh, you know what I can do? Hopefully it doesn't mess up anything for the stream, but I can temporarily disconnect the Ultra Studio for a second because I'm not using that camera right this second. Alright, so then let's plug this in. Deep. Is there any indication that this is working? That's a negative. But then this might be one of those silly cables that is directional. I forget. I've had USB cables that are cheap and like you can only install them one way, which I think is ridiculous, but okay, well, the problem might be the cable. I'm not seeing signs of life though with the Raspberry Pi. So I think what I'm gonna do first step, is I'm gonna disconnect. Oh boy, that's hard to get out of there. There we go. I'm gonna disconnect the cable that's on the front of the board, and I'm instead going to use this cable here, which is a USB-C to micro USB, which is the same connection that's on the Raspberry Pi. So we will take this and we'll go ahead and install that there directly, and then plug that in here. Well, I guess it doesn't really have any LEDs on it, though, does it? Other than, like, if you're actually sending signal out to GP3 or GP4. So that's... Okay, so let me just see then, I guess, if it shows up on the system. Wanted to see if anyone had like an online flashing kind of tool, but it doesn't look like that's... I've not worked with the Pico before, so oops. I guess the thing to do here will be to... Actually, first let's get back to the stream so I don't lose track of that. System information, and let's go USB with webcam. Oh, let's see. I'm gonna disconnect that and see if does that. Still showing there. What is that? Is that still... Is that the same thing? Huh. I wonder why it's still showing once it's disconnected. That's interesting. Well, alright, so it does appear that it's showing up, but I can't quite tell if it's working properly because it's still showing up even once it's unplugged, which is weird. Like this should be real time, I think, the way this app works. But let's... Alright, so USB. Okay, so it's not showing anymore. So then, if we remove again the plug this in. And guess we'll quit system information again. I'm gonna say keep it in dock so I don't have to keep finding it. Okay, so let's quit. Let's open it again. I didn't expect to have to do this, but okay, now it's not showing. For that to work before. Well, anyway, we'll have to figure it out. I'm not seeing evidence of it right now. Let me just quit system information again, open it up again just to make sure, because it seems like it's not that reliable for this. Yeah, no, it's not showing. So don't know about this USB connector to the front panel, but the Raspberry Pi itself seems to be working. So worst case scenario, I'll do something clunky like remove that front panel USB connector and then just go straight to, go straight through with a cable or something to the Raspberry Pi so that I can affect it more easily. But it is at least working on some level. It does show up on the computer. So there we go. That'll be good enough for now. I will troubleshoot any additional issues later. Because I don't think the problem has anything to do with anything other than maybe maybe this guy, like this kind of cable to here. So I'm not super confident in that, but everything else I imagine is probably fine. So I'm not going to dig into troubleshooting right now. We'll just go on to another aspect of the build and start building the VCOs. I am, however, going to take a quick break. And sorry, just prepping my signage here. Yeah, and let me also. Okay. All right, so I'm going to take a quick break. I will be back in just a few minutes. And let's see, it's 12:45. We've got an hour and 15 minutes. Let's see if we can get one of the VCOs built. And we'll go from there. Okay. More water. Okay, I can't tell how delayed my view of the stream is here on Twitch. It seems quite delayed, or else it's just not updating at all. Hard to tell. Let me make sure that the stream itself is actually working correctly now, because I did unplug. Did I mess myself up when I did that? Let's see. So what if I... So, I appear to have a little bit of an issue here. I guess I kind of messed myself up when I went and unplugged the Ultra Studio while it was connected to OBS. I fixed this before, but I don't remember how. Thought in the past that just kind of disconnecting and reconnecting was all that needed to happen. Let me just verify that you guys are gonna probably lose me for just 1 second here, because I need to actually, maybe you won't. Let me try to fix this. So what's the problem there? shot myself in the foot a little bit there. Because my overhead camera appears to be frozen, I think. Let me just double check. Is it? Oh, no it's not. All that and it's actually okay. Silly me. Okay. So let's get back to it here. I got confused because my view on the Twitch stream was not updating, and then it looked like, because I guess I hadn't changed positions of things enough to be able to tell, it looked like things weren't updating on in OBS either, but it turned out they actually were, and I'm just silly. So there we have it. Okay, so should have thrown this garbage out. Alright, so this in theory is a working module. Possibly the USB connection on the front panel is wonky, but that would just be a parts problem and not actually anything else, because it doesn't, there's no solder or anything to connect that, so it just kind of runs through. So yeah, I'm going to troubleshoot that on my own time. Don't need to really waste stream time for that, so let's move on. Let's see what makes sense to dig into next. I think it's going to be the VCOs. We'll probably only get one built, if that. We'll see. Again, I'm slow. I've got an hour left. I'm stopping at 2. So, Eastern time. Let me just, being the completist that I am, let me just mark these. Probably should have taken a little food break, but that's alright. I don't really have enough time for that, and it's not that necessary. So let's just real quick take a look. So it looks like, just based on this PCB here, if I look at this, we've got 1 pot, 4 jacks on the front side, and maybe, I'm guessing it's going to be a trimmer that's accessible through the front panel here in these little holes. This is kind of off screen, isn't it? Let me get that more visible to you folks. So sorry for the glare there, but let me try to get it. So the panels have these little holes here, and if I look at the PCB, it says trim other side. So, and I know there's trimmers included in the kit, so what I'm assuming it's going to be is there's going to be a trimmer on the PCB that is accessible through the front panel to tune the VCO, so that you can, or I should say calibrate the VCO basically, so that you can make sure it's tracking as close as it can. And I guess we'll see in the information whether or not it's expected to track more than an octave or 2. I don't really know based on the design of the circuit. But so it looks like we've got a bunch of resistors, a handful of capacitors, the TLO74 chip, On the opposite side will be a pot, a trimmer, 4 jacks, and we've got 5 transistors. So a relatively simple build. Let's see what the situation is. There's also these passive malts. That would be a really simple thing to build. That'll take probably 15 minutes because there's almost nothing to it. So let me just read through the information here and we'll try to figure out what's next and how far to go with this. So it says voltage controlled oscillator. The voltage controlled oscillator, or VCO, is the core sound of our synthesizer. Since our modules are based on the subtractive synthesis method, we want to produce a harmonically rich sound for sculpting. Sawtooth and square waves are the best wave shape primitives for subtractive synthesis, offering a wide range of harmonics. Sawtooth waves produce a rich, crisp sound with both odd and even harmonics, somewhat reminiscent of string instruments. Square waves, containing only odd harmonics, have a sound similar to woodwind instruments. For circuit simplicity, we'll only produce a sawtooth oscillator. Square waves can be obtained from a sawtooth using a comparator later on. Design-wise, oscillators are tricky for music applications. Because the human ear has a quite accurate perception of pitch, and the frequencies needed musically can span about 3 decades, from 40 hertz to 4 kilohertz. I've never read the word decades used in that context. I wonder. That's interesting. Anyway. Due to the constraints on circuit size and ease of building, the oscillator is musical but not accurate beyond about 3 octaves. Okay, so there you go. We can expect pitch tracking for roughly 3 octaves. It could be honed by matching transistors and using temperature compensated parts, but I chose to make it as simple as possible to build and calibrate. That being said, this module probably uses the most parts in Build Your Own Modular. This design is a derivative of Electronote's VCO Option 1 and Ray Wilson's original MFOS Sound Lab oscillator, but variations on this idea go back a long way. A simple summary of the circuit is that it is a ramp core oscillator that is driven by a voltage-controlled current source. Okay, VCO module. VCO is very simple to use. There's really only one control, and that is pitch, aka frequency. The frequency knob has a wide range from a very low clicking sound at the low end to a very high, almost inaudible pitch. The way it works is you set a fundamental bass pitch with the knob, and then you can control the pitch externally through the volt per octave input, which is our musically scaled input. You can plug in keyboards, sequencers, and things like LFOs to get pitch changing sounds. The output is simply the saw, and you can patch this further up chain into a VCA and VCF to alter its sound. Sync in and sync out are simply a way of synchronizing the VCO with another VCO. This lets you make one VCO try and match the pitch of another VCO, and when the two oscillators are at very different frequencies, you get some very nice timbral effects. To make sync work properly, both have to be CV controlled at the same time. Specifications. Input current. Plus 12 volt rail is about 10 milliamps. Negative 12 volt rail is 10 milliamps. Construction. Build time 1 hour each, or 1.5 hours together. Difficulty medium. VCO circuit description. The foundation of pitch controllable oscillators in electronics and software lies in a system of counting and resetting. A device starts counting up, and then at a defined high threshold, the count resets to another low threshold, which in turn sends the count back up, creating a repeating cycle. In electronics, this is known as a relaxation oscillator. For our analog oscillator core, The count, quote unquote, is the continually rising voltage created by the charging of a capacitor in a circuit known as an integrator. Then a device called a comparator acts as a threshold mechanism. It compares the capacitor's voltage against a reference voltage and quickly discharges the capacitor down to a certain voltage. Then the cycle starts again. The integrator is in the schematic is around U1A. It starts ramping up its voltage from whatever state it is in. Its voltage output is fed into a comparator, U1B. So let me just take a look at the schematic real quick. Or actually, let's get the PCB in front of us. Why don't we break these out to continue this, because I believe yeah, so U1A is one of the pins on the TLO74. Alright, let's just break these panels out. Maybe we'll build the passive mult too while we're at it, why not? Maybe do that first, see how far we get, and then get into the VCOs maybe. Let's see. We've already established that I'm on the slower side when it comes to building things, and I don't have a full hour, so we'll see what happens. I think maybe what I'll do is maybe we can get all the parts together and put aside, and then start the next stream by building the oscillators right away. Breaking out the PCB for the passive mult right now. This thing, I mean, this will really just take about 5 minutes to build, so, because it's genuinely just a couple jacks that are tied together via the PCB and a panel to hold it all. So you can see the PCB is literally just jacks. It's 1, 2, 3, 4, 5, 6, 7 jacks. But I'm going to finish what I was reading, though. I'm not just going to bail on that. Once I get this out. More scrap. Are these blanks? Oh no, that one's not. But this one looks like it is. I'm noticing that the panels here, like there's the actual panels for the module, but then this here says voltage controlled oscillators, and it's got spots for screws. And if you flip it over, it's got that cool splatter pattern. So I guess maybe that can work as a blank. I don't know. I'm curious. But anyway. I was trying not to break off the tab that says VCO, but I broke it off anyway. Whoops. nubbins off these guys here. Okay. More. There's the panels. And I guess I'm going to treat this like it's a blank or an empty. Like if it's, I don't know if it's meant to label things in the system. I think maybe, I know there's a spot later in the book that mentions that the passive mults and things were kind of an afterthought, so maybe the original idea was to, you know, label things, like label the VCOs with a panel, but then maybe he added in the passive mults instead and other circuits. I don't know. I have no idea. But it makes for a cool blank. I really like that pattern there. It's pretty. So, I'll take it. Alright, so where was I? Doobie-doo. Alright, so again, we're working off this guy. So this chip here, the TLO74, is, which I believe, if I remember correctly, that's just a dual op amp, I think. That's labeled U1. So the integrator in the schematic is around U1A. It starts, which it would be 1/2 of the dual op amp, if I'm not mistaken. It starts ramping up its voltage from whatever state it is in. Its voltage output is fed into a comparator, U1B, which compares the two voltages at its inputs and outputs, either a high or a low. The reference voltage at the negative input is the threshold limit of our waveform. The positive feedback provided by R6, looking for where R6 is in the circuit. It's right there. Positive feedback provided by R6 gives the comparator hysteresis, which means depending on the voltage's direction of travel, it will have a different threshold. So rising, the threshold is higher, and falling, the threshold is lower. The output of the comparator feeds a MOSFET across the integrator's capacitor, shorting it to reset. Historically, this was done with a JFET, but they are becoming rare in TO92 packages, so instead I used a MOSFET, as they are still very common. R2 is not actually needed, but I found it helped dampen the fast switching of a MOSFET that can cause some noise interference. R6 does cause the waveform to get a bit curved at the lower frequencies, but this is a compromise for simplicity. The log driving circuit. The integrator in a VCO must be driven by a negative current sink, to function properly, which causes the integrator's output to rise. This current is provided by a voltage to current converter. In music, pitch does not have a linear relationship with notation. A middle A, A4, is defined as 440 Hz, and an octave above it, A5, is 880 Hz, which is double the frequency. Another octave up, A6, is 1760 Hz, which again doubles the frequency. If we use a knob with a linear relationship to pitch, the lower octaves would use less of the knob's rotation, while each subsequent octave would occupy progressively larger portions of the rotation, and the knob would have no range at all. To make pitch control more musical and intuitive, a pseudo-standard called 1 volt per octave has been adopted. This means that for every 1 volt increase at the CV control voltage input, the pitch doubles, corresponding to a 1 octave increase. To achieve this, an op amp, U1D, is configured as a constant current source. This current source increases logarithmically, compensating for the exponential nature of notes. By doing this, the VCO can provide a linear control voltage to pitch relationship, ensuring that equal increments in control voltage result in equal musical intervals. The log converter is driven by U1C, which sums and attenuates the control voltage from the knob and volt per octave input to drive the log input. That must mean drive. I'm assuming that input to drive the log input of the converter. Trimmer RV2 tweaks this relationship. The output. We connect our output straight from the integrator output and use a capacitor to block DC from being seen at the output. Construction. This is a pretty straightforward but busy build. Solder the components on the top and the bottom as before, then place on the front panel and screw in all the nuts on the jacks and pots. Tuning calibration. This is the only calibration you have to do for the entire synthesizer. You don't have to do it, but if you want to use a keyboard or have two oscillators track the same pitch, you should do it. The blue trimmer, RV2, is the trimmer. You will need a small flathead screwdriver, a frequency meter, and a voltage source such as a keyboard with a volt per octave out. For the meter, you can simply use a tuning app from your smartphone's app store or use a guitar tuner. Set the oscillator to a pitch. I like to set it to the lowest decent C my tuner can pick up. Plug your keyboard into volt per octave. Make sure it is 0 volts. Use a voltmeter to verify that the lowest C 0 volts. The lowest C equals 0 volts by putting the probes on the jack tip and shield. Press 1 octave up, the next C, and read the pitch. If the pitch is higher than an octave up, then trim the trimmer so the pitch increases by the same amount it is off by. If it is lower, then decrease the trimmer so it goes down by the same amount it's off. It's counterintuitive to be tuning the opposite way to fixing the pitch, but this is how it works. Then press the original lowest C. It will have gone out of tune. Tune it back to C, then press the next octave up. It should now be closer. Repeat steps 2 to 3 until it works for about 3 octaves. Yeah. Notice how the audio jacks share a ground pin. Place them both in the socket before soldering. Be careful not to mix up the TO92 packages. There are 4 different types on this board. Some are transistors and some are IC regulators. Double check the text printed on their package bodies. There are 2 bills of material on each side of the VCO bill of material page, so it gives you a checklist for each module built separately. Cool. I think that's about it. Yeah. Then from there it gets into the mixer and attenuverter, which mixer will be helpful to hear things, but we can test these other ways. So what I'm going to do, given that it's almost 20 after 1, or 1300 hours, depending on how you view it, I'm going to build the malt first, and then I'm going to start sourcing the parts for the VCOs. And there is a chance that I would be able to get through a VCO build if I'm quick about sourcing the parts, but it's not a given, and the malt will take like 5 seconds. It's such a simple circuit, so let's start there and see what we can do with that. So I'm going to clamp this in here. I'm going to go ahead and place all the jacks, then I'll place the panel, then I'll tighten them down, and then I'm going to solder everything. Again, just hand tight. So that guy's there. Several of these jacks share a ground in terms of where they get soldered. So they alternate kind of facing each other and not facing each other, depending on where the ground is located. Oh, that one's pretty bent. Let me fix that. Alrighty. So that's those. So then from there, now J1. Okay, so I'm gonna assume J1 will be at the top. I wonder if I should double check that. But yeah, my guess would be J1's at the top and J7 is the bottom, but let me just double check because I think that was at the back of the book along with the enclosures and things. Just want to make sure I'm installing the panel the right way. Not that it'll matter all that much, but being back here with the enclosures. There we go, passive malt. Yeah, alright, so my assumption was correct. So it says, this was a little bit of an afterthought, but I discovered that there was a need to find a way to split CVs for multiple destinations, such as sending them to both VCOs or even joining signals together in a basic way. This could be done with a malt, and there was a little sliver of panel left at the end of the case, so I made it. The way it works is very simple, but sounds complicated. There is no power, which is why it's a passive, or which is why it is passive. We are just connecting all the tips of the jacks together and all the grounds together. There is one little trick though, so we can get multiple malts in one design. Jack 4's switched input is connected to Jack 3's tip. This is taking advantage of the switch inside the jacks. It means that if Jack 1 has a signal going into it and Jack 7 is connected, when Jack 4 has a jack inserted into it, the connection from Jack 1 will be lost and the signal will be directed to Jack 4. This means Jack 1 through 3 can be used as one malt and Jacks 4 to 7 as another separate one. However, if more connections are needed, Jacks 1, 2, 3, 4, 5, 6, and 7 can be used as a single connection, skipping Jack 4. Oh, did I say 4? 1, 2, 3, 5, 6, and 7. Yeah. You can also use this to quote, mix together some outputs. I placed 1K resistors on most outputs so the sound can be mixed this way, but it may behave a little strangely. Yeah, that would be expected. Because there's nothing in there in the design to buffer the voltage, so it could move around. You could get voltage drops and things, which is, I think, what he means by it could behave a little strangely. So 1, 2, 3, 4, 5, 6, 7. So let's just go ahead and build this little guy real quick. And then we'll start pulling the parts together for VCO. building all the passive modules today, I guess. Huh? Most days I don't get too hungry till about 2 p.m., but today I'm wondering if I'm gonna make it to 2. I'm very hungry. Let me just check something here real quick. We're getting close to the end of the stream here, so I'm gonna start launching into my public service announcement in just a bit. I do one of these on every stream lately, and I will continue to do them until situations here in the United States improve. Yeah, we've got some concerning stuff going on here. For those of you who are not in the United States, I am glad for you. I mean, unless of course you're in a location where the rule of power is even more authoritarian than what's happening here, then, you know, to each their own. If you're okay with that, then that's up to you. But here in the US, for a long time, we kind of at least existed with an illusion of freedom, so to speak. And, you know, we had some ability to move within these systems of power and kind of be autonomous. But things are getting a little strange, and above everything, my main concerns are humanitarian in nature, because I'm really not in any way okay with concentration camps, and those are being developed at an alarming rate. And yeah, I know some people would disagree with calling them that, but they are concentrated. I mean, you're concentrating individuals at a location to, keep them out of circulation, essentially, for whatever reason, be it that they're deemed to be unsavory in some way. But the people that are being taken to these places are really just anyone, like legal, upstanding citizens, that just happen to have skin of a certain color and are therefore being whisked off to these detention centers. And some of the stuff they're doing in terms of just the size of the places they're building, there's a lot of concerns there. And the contracts that they've laid out for these, I mean, they're worded like operational bases that we would build in other countries, but they're, for here in the U.S. And there is wording, if you take the contracts literally, which I think has in the past proven that to be something we should do as a precaution. These things are worded in such a way that they're like planning for military operations on U.S. soil, and it also mentions multinational operations. So there is a question of, well, what does that mean? Who are these multinational operations? What other countries would be involved in an effort like this? So that's all a bit strange. But above everything, I mean, there's atrocities being committed in these locations. There's torture happening. They're, is very inhumane treatment, and you know they're disappearing people. There's like I think like 1,500 people from one of the Florida detention centers that are just unaccounted for at this point. 1,500 people. I mean, that's a lot of people to just disappear. Like, so there's some really concerning stuff going on, and I would say that the argument I make is anyone who is a peaceable citizen, who is keeping to themselves, they're not, you know, forcing their opinions on others, they're not, you know, because in my opinion, like I don't like to get political on these streams. These streams are meant to be inclusive. I want to include everybody. But if you are of the mind that the stuff that's happening here is good, then you're probably not going to agree with me, and I do need to speak my mind, because my whole thing with all of this is we can't stay silent. I mean, pretty well proven historically that the whole way that the Holocaust happened was because people just let it happen, essentially. It wasn't going to happen to them, so they stayed out of it, and if one of the like sort of torture camps or concentration camps, whatever you want to call them, was near their home and screams were audible and stuff, you just put another pillow over your head to sleep at night, close the drapes tighter, you know, and that we can't do that here. We've got to be better than that. So anyway, that just real quick to insert there, that is a malt that is done. So how many minutes did that take? I don't know, maybe 10, but that's because I'm slow. So we've got a malt. And yeah, so I'm just very concerned, and I think we have a lot to be worried about in all of this, and I don't think we can just let it go by. And we've got to use our voices. We've got to speak up. We've got to push back. We've got to stay peaceful, because I don't think violence is going to do anything other than have violence be squashed. But we have to do something, because this can't stand. We can't let this happen in this country and let this happen to these people and just sit idly by just because it might not happen to us. Because eventually, the other thing you have to keep in mind, these detention centers are for profit. They are for-profit facilities. In order for them to maintain profit, they have to be putting bodies in there. So it may not be you today, but what happens when they run out of people that match their current profile? Then who goes in there? How do they account for making the profit? It's all very, very concerning. So we need to speak out against this. We need to do everything we can to stop it with, you know, peacefully. And we need to me, one of the big things right now is we gotta create community. We gotta maintain community. Part of the reason I started streaming again is because, you know, in the area that I'm at here, out the boonies, like I haven't established much community out here yet. I've been out here for a while now, probably getting on 4 years, but haven't really managed to achieve much in the way of community. So at the very least, I want to use my, you know, connections to people internationally and globally, you know, to foster some of that and to be able to hopefully provide something of value to the world. And I am going to start working on establishing local events and things. I've been saying I'm going to set up a synth night forever, like even just like a synth petting zoo kind of thing. I have the means to do that in terms of enough gear to be able to just kind of set up and have something that could be enjoyable for folks. But I need to figure out a venue and stuff and timing and things. But alright, these are, how many pins are, yeah, I think it's the ladder there, that's the bigger one. Sorry, I'm sorting parts as I talk through this as well, but yeah, but we need to keep our community strong. We can't just get absorbed into the, oh no, it is the smaller socket, okay. We can't, like, the digital environment is a strange thing. It's very disassociative, and we got to be careful not to get, like, sort of eaten by the machine, so to speak. Like, we need to not get sucked into it and just disappear, because I feel like that is kind of happening in a lot of ways. There's like this sort of parasocial thing that's replacing actual social connections and stuff, and it's really not the same. So yeah, anyway, if you, like me, are concerned by the stuff happening, just all I can say is please don't stay silent. I think we need to, like, audibly stand against this, be a problem. We can't let it govern us. We gotta step outside it somehow and, you know, potentially starve this system. I have been participating in the resist and unsubscribe movement because I do think that one of the ways that we can get at this most easily is to stop funding, with our dollars anyway, with our, you know, consumer spending, the companies that are backing this stuff. I think that's going to be one of the most notable ways, you know, as far as any of these entities are concerned, like any of these corporations and stuff. I think the only way we can really get them to stand up and notice is if they start losing money. So I have unsubscribed from a whole ton of services and things that I was using. I am hoping that Anthropic doesn't, I'm not aware of any sort of unsavory funding or moves on their part. I could be I could be in the dark about that, so if anyone knows things that I should know in that regard, then please let me know. But I have been getting a lot of use out of their tools lately, so I am hoping that they stay above board and don't also become a company that I feel like I need to boycott. But sorry, I'm just looking to see. All right, got the V100K pot, and we need our trimmers. Should be one for each. Yeah, I'm probably just going to get to the point of getting all of the parts sorted here, and then we'll start the next stream with the VCO builds. And what I might do between now and then is I might also get the parts sorted out for the next two, like the mixer and the attenuators. Is it attenuators or just attenuators? Anyway, yeah, I might end up going ahead and getting all that stuff sorted so that we can just dig in and we don't have to spend time on the stream digging through parts. That was sort of an oversight on my part here, but so, let me pull, I need 8 Tonka-Con jacks. Get all this mess out of here too. Gotta figure out what I want to do with these. Just for now, kind of set them out of the way up there. Alright, I need 8 jacks. Two, 3, 4, 5, 6, 7, one more. There we go. So there's the 8 nuts for the jacks. Alright, so let me just put some dots here. We've got that. We've got both of our trimmers. Both of our pots, both of our sockets. Got the DIP 14 socket. Didn't pull out the op amps yet. We're gonna need 4 diodes total. 7,000, so we need 2 of those, 4 of those. 79L5 regulator. Let me just look at this real quick. So what's the footprint for? Alright. So let's get the capacitors sorted out here. And the diodes. Since they're in the same package. Alright, so we need 4 diodes. So we'll just go ahead and take these out of this bag since there's 4 of them there. Is my other camera even working there? It doesn't look like it is. Huh. I wonder what happened. It's on, but I guess the capture card for it isn't working. Lovely. Alright, well anyway. So these can go back in the capacitor bag, because they're not needed. Oh wait, maybe I should wait until... So we've got 4 diodes. So 100 nanofarad. How many of those were there? There's 31, so that's the 104 on the card. So loose. Yeah. they're all ceramic, so we're not going to need any of the electrolytic capacitors here. There's no LEDs. I don't know if we're going to need any of those loose capacitors in there, but so we've got 4. Alright, so we need 1, 2, 3, 4, 5. 2, 3. So we'll do 2 sets of 5. There's 1. 1, 2, 3, 4, 5. There's 2. Set those aside. I'll set them maybe down here to get them out of the way. Alright, what else? Let me just mark those. C8 is a 220 picofarad. I might have used one of these already. Is that off this card? Oh, these are the ones that are so hard to read. Let's see. I might have to take them into the other room. Maybe not. Maybe I can read it here, but it's very difficult. Looks like that says 471. Is that possible? Or am I misreading? Yeah, 471. Okay, so that's the 470 picofarad. And that's alright. So these aren't needed, but these might be. What do we got? There we go. 221. So hard to read. Alright, so we will just cut 2 of these. And then 1 nanofarad ceramic C4. These are going to end up being loose. Yep. Should say 102 on it. Alright, that's one of them. Let's get the other one. There's the other 102. There's just one more floating around in there somewhere. Alright, so that's all our capacitors. And then we have resistors. We've got 12 minutes, so guess we will get through the rest of these. Although, like before, the resistors I do tend to like to place as I source them, just because, unless I label them, but yeah, I think I'm gonna hold off on those, and because I think I want to just place them while, as I find them and source them, because then I'll set both PCBs up I can place all the resistors and then the diodes and just start building basically. And we can just build both of them at the same time, because why not? And yeah, I think that's how I'm going to want to do that. So I'm going to pause here. I might, well, I'll definitely take the time to put the parts together for the next two modules as well. But what I'm probably going to end up doing for these is I'll probably get the resistors placed. I might even solder them, we'll see. Or maybe I won't touch anything again before next week, because that's kind of what happened this time. But let me set those out so that they're kind of ready to go. Okay, so I would say that's some good progress this week. We got 2 modules done and 2 more started, which is pretty decent. I would have liked to have gotten through the VCOs, or at least one of them, but that's okay. So our results from today, we've got a potentially working micro module, which I just need to do some testing with and kind of troubleshoot some things to see if the Raspberry Pi is being recognized when it's connected to the system, because it does seem like if I plug it in directly, it's recognized, but if I plug it in through the USB-C connection here on the front that connects back to the Raspberry Pi, it doesn't seem like that's working. So I'm gonna have to take a look at that, see if I can sort out what the problem is. And worst case scenario, it's kind of dumb, but if I have to, I can just run a cable through the panel, do things that way. But I don't think I should have to. I think I can probably sort out what's going on there. And I'm also just gonna put this connector under the microscope, because a couple of these connections look a little sloppy, so I just want to make sure that there isn't an issue there. And we have a mult. And you know, the one thing I didn't do is I did not verify continuity with this, but that's pretty easy to do, so let's just do it. Make sure everything's good. So, assuming we have continuity, we'll get... First I'll check ground, I guess, because I think their ground is shared, if I'm not mistaken. Well, alright. Okay. Cool. Yeah, so we have continuity from the first jack to the last jack. So I really should just double check that via like actually plugging cables in and, you know, checking continuity off the cable tips, but it looks good for now. So, thanks for hanging with me out there. I'm gonna install these into the system, and I'll do some troubleshooting on the micro module and and just make sure everything's working as expected. And then next stream, let me turn this guy off because we don't need this. So then on the next stream, we'll start right in with the VCO builds, and we'll just work on them side by side. And we'll go from that into the mixer and the attenuators. And I think there's possibly only like 4 more modules after that. I have to double check, but we're making progress. And now that I think about it, I do believe that these blanks actually serve a purpose, because I think there's not enough modules to completely fill the enclosure. And I think you do end up using the blanks to fill in space. But I have to double check that, but I think that's true. So yeah. Okay. Well, this has been another installment of building the Clacktronics modular. Again, you can find this at thonk.co.uk, and also I think there's links from the Clacktronics site. I will post links to those resources in the description, at least on YouTube, once this goes up. And I'll go back to last week's stream and also add them there, because I don't think I've done that. That was an oversight. And yeah, once we're done with this project, not to get ahead of myself here, but the next step is going to be I'm going to be building the Antinous stepbrother. So if you're at all interested in that, that's a remake of the sequencer that was designed for the ARP 2600. And since I have one of the Korg ARP 2600s, or CARP 2600s if you prefer, I'm going to be building that to go with that system. So that should be fun. I have the case and the full kit, but I just need to run through the bill of materials still and make sure that everything's good there. It has been a while since I originally received all that, so I just need to make sure I've got everything and haven't lost track of any of it. And then after we get through the Clacktronics modular, we'll move on to that kit. After that, I don't know what we'll be getting into, because I have a bunch of things that I still need to build. I have a compressor, like a 19-inch rack compressor. I believe it's stereo. It might be a mono compressor, actually. I forget. It's been so long since I looked at the project. I have almost all the parts for that. There's a few things I have to source, so I'll have to look into that. Wishing I would have gotten that stuff sourced before all the tariff nonsense, but it is what it is. Most of that stuff I have already. I have almost everything for the kit, but there's some larger components that I will need to locate. Then there's also the noise toaster, which it's kind of a rabbit hole with that, because there's a bunch of other information that I wanted to sort of consume along with that, because there's a whole book that goes with it and everything, and that I probably can't just work through on the stream, I would imagine, because that is like copyrighted material and stuff, and I don't really see O'Reilly or whoever publishes the Make stuff. I think it's O'Reilly. I don't really see them giving me permission to just read that book on a stream and like go through it that way, so we'll see. I'll probably have to kind of take the material and do something derivative from it. But yeah, that gets into similar territory as the build your own modular stuff, just because it's some basic circuits for you know, compiling a basic synthesizer. But yeah, and then there's a lot of other little odds and ends kind of projects that I have around, but we'll see. So for now, and I guess my overhead camera is just frozen based on what I'm seeing on the stream, so that's a shame. So sorry about that. I can stick my head in awkwardly over here. I think what I'll do is I'll go over to the other room, to the desk, and wrap up the stream from there. I will say it was nice not dealing with the latency in the monitoring today, because I did not use my knocking things on the floor. I did not use my AirPods for monitoring today, and it was much more enjoyable to just have headphones and be hearing things in real time. Okay, so I'm gonna get going. Thanks for hanging with me today, and yeah, I don't really feel like I can overstate the importance of the PSA I made earlier, but also, again, don't love getting political on these streams, so I don't want to overdo it, but super important. Let's not just sit and let this happen. It's not okay. So anyway, that's it for today. I will be back on Wednesday, same time, different channel. I haven't quite figured out what I want to do for that stream yet. I'll get that sorted out today. It's very possible that I might be using that stream to kind of look at the RC600 and getting comfortable with how to compose with it, because it's a little bit different than the RC300, which I'm upgrading from. But yeah, I mean, it's already, you're hearing it now as part of the loops that are happening in the background, but yeah, we'll see. I feel like that will probably be a more guitar heavy than synth heavy stream, but we'll see. I don't really know. It's also possible that I might use the stream for working on this composition that I've had set up as a patch on the modular for a long time, and I'm not done with it yet. So maybe we'll work on that composition together too. I don't know. We'll see. But that will be Wednesday, and then Friday I'm gonna do another, you know, digital painting stream, I would imagine. The one difficulty that I have at the moment is I have a bunch of software that I'm writing and trying to get out the door, and if for any reason that stuff starts taking precedence for any, you know, over some of this other output, then I might have to kind of shift around to refocus that. But for now, I'm going to keep the live streams going, and because I still have, you know, 2 other days of the week and a little bit of time on the weekends to work through the software stuff. So yeah, so that's it for now. Thanks for watching. Thanks for hanging. I will see you in the next one. See you Wednesday or Friday or next Monday if you're only here for the DIY stuff.